Hello, I am Dr. Bob. I am going to show you how to install and set up the Yuasa Twisting Test Jig FT. The installation and setup will be similar to what I am doing in this video if you are using any of the motor drive units TCDM111LH or DMLHB or DMLHP or DMLHPR. There is one key difference among them though. With the motor drive units TCDM111LH or DMLHB, you set reciprocating distance or angle by adjusting a cam like I will do in this video. With the motor drive units DMLHP or DMLHPR, you set reciprocating distance or angle using the touch panel like I did in the Yuasa CS setup video. I am using the motor drive unit DMLHB. We are starting with the pieces separated as if you have just removed them from their shipping boxes. Position the motor drive unit with the rotary shaft facing to the left. There are only a few tools. First is the T-type hexagon bar wrench. I call it an Allen wrench. It is a 3mm hex wrench. Second is a locking latch that is used to lock the motor drive unit in place when you adjust the cam follower to set the reciprocating distance. The cam follower is inside the adjusting port. Keep the cover on the unit for your safety when operating the machine. Note that the DMLHP and DMLHPR do not have an adjusting port. Third is an open-end wrench, 8mm on one end and 10mm on the other end. Those tools should be in the shipping box. I also will use my own 2.5mm hex wrench. This is the linear output shaft which is used when the DMLHB or DMLHP is used as a linear drive unit. It attaches through a hole in either side of the motor unit. Only attach it when it is being used. Make sure you never ship the motor unit with the linear output shaft attached. You can damage the motor unit and the shaft. Note that the DMLHPR is rotary drive only. It does not have a linear output shaft. The FT is driven by the rotary drive output of the motor unit, so we will not be using the linear output shaft in this video. This is the motor unit AC power cord with a 3-prong to 2-prong adapter for use when needed. This is the rotary shaft cover. It is installed over the rotary output shaft whenever the rotary output shaft is not being used. This is the output shaft flange. It mounts on the rotary output shaft and is required to attach some of the jigs. It is required for the FT jig. When FT machines are shipped from the factory, the output shaft flange is already attached. This is the connecting base. It mounts on the bottom of the motor unit and to the bottom of the FT jig. This keeps the motor unit and the jig rigidly attached to each other. This is the controlling string, which I will explain later. This is the swing plate with an idler to hold the controlling string. The swing plate mounts on the output shaft flange. And this is the FT jig with its following slider and a clamp to hold the controlling string. There are a total of 4 sample clamps. I have already installed 3. This is the 4th. And there is a safety cover which mounts over the face of the motor unit and the jig to provide for the safety of the operator when the machine is running. Let's take a look at the touch panel on top of the motor drive unit. Note also the large red emergency stop switch. Let's press the emergency stop switch. Immediately, the motor unit will stop if it is running, and we will get a red warning on the touch panel. To reset, rotate the emergency stop switch clockwise to release it. Press and hold the reset button on the touch panel. Press the home button. Now we are back where we started. Now let's take a closer look at the touch panel. This is the jog button. Touching the jog button causes the motor unit to move a small amount. Holding the jog button will cause the motor unit to continue to move. I do not have the safety cover attached. That means the motor unit will not operate. I will touch the jog button. Immediately a red warning shows. The motor unit refuses to operate. Touch and hold the reset button. Touch the home button. Now we are back where we started. For the rest of this video, except for the tests, I will disable the safety cover switch to better show you the actions of the machine and jig. I have disabled the safety switch. Press the jog button and hold it, and it works. Hold the jog button and the motor unit continues to operate slowly. Tap the jog button to make the motor move only a small distance. Press and hold the jog button to make the motor continue to move. Let me do that again while looking at the rotary output shaft. I have placed some painter's tape on the shaft so you can see the rotation. I'm tapping the jog button. Now I am holding the jog button. It will rotate back and forth. Tap again. A short tap. A long tap. Let me do it one more time while looking inside the adjusting port. But first I must remove the adjusting port cover. Remove the top two screws. It is not necessary to loosen the bottom two screws with the DMLHB. You do need to loosen the bottom two screws with the TCDM111LH. Lift the port cover and set it aside. For your safety, it should be installed any time the motor unit is operating. Note that there is no adjusting port with the DMLHP or DMLHPR. Now we are looking inside the adjusting port. I am holding the jog button. I am tapping the jog button. Holding. Tapping. While we are looking in the adjusting port, let's see how we adjust the reciprocating distance and reciprocating angle. To make the adjustment, we have to use the jog button to line up the mechanism a certain way. This is the cam follower. This is the scale. To make adjustments, the slot must be up and down. This is one of the two locating holes. To see the second, we must move the mechanism. This is the second locating hole. During each full reciprocation, the slot will be up and down 2 times, but the holes will align only one of those 2 times. The 2 locating holes must line up exactly before you can push the locking latch into the 2 holes. You can use the jog button to move the 2 holes into close alignment. Inserting the locking latch will lock the cam follower into position so you can adjust it. It also locks the motor. I recommend turning off the power to the motor unit before inserting the locking latch, just to make sure you don't try to run the motor while it is locked. I have turned off the motor unit. I am going to insert the locking latch. Now the cam follower is locked and the motor is locked. As I mentioned earlier, note that this step is quite different with the DMLHP and DMLHPR. Rather than make the cam adjustment, you enter the distance or angle using the touch panel. If you are using the DMLHP or DMLHPR motor unit, please refer to the Yuasa CS setup video to see how to make these settings using the touch panel. Let's take a moment to look at the meaning of reciprocating distance. In this table, we see the value on the scale in the top row. The second row shows the reciprocating distance. The reciprocating distance is the same in millimeters as the scale, except it is plus and minus the value on the scale. The third row shows the reciprocating angle. Note that every plus and minus 10 millimeters on the reciprocating distance translates to plus and minus 45 degrees on the reciprocating angle. A scale value of 40 would be plus and minus 40 millimeters of reciprocation distance and plus and minus 180 degrees on the reciprocating angle. We can see that the reciprocating distance is currently set to 40 millimeters. We will set it to 20. We will move the cam follower using the T-type hexagon bar wrench. Keep the hex wrench in the cam follower because the cam follower could fall when it is loose. Do not turn the cam follower more than 90 degrees because it could come apart. Turn the cam follower counterclockwise about 90 degrees. Move the cam follower down using the hex wrench until the cam follower is centered on 20 millimeters on the scale. tighten the cam follower by turning it clockwise. Now the reciprocating distance is set to plus and minus 20 millimeters, and the reciprocating angle is set to plus and minus 90 degrees. Remove the locking latch. Don't forget to remove the locking latch because it has locked the motor. Now you can turn on the power to the motor unit. Let's go back to the touch panel. There are only a few controls we will use in the setup: the home button, the count button, the speed button, the start-stop button. Tap the count button and you will be able to reset the number of reciprocations. Touch and hold reset for a couple of seconds. The count goes to 0. You can set the target number with the touch panel. It is currently set to 20. Touch the number for target. Let's set the target to 12. Tap 1 and 2 and enter. Press the home button to go back to the main screen. Tap speed to set the reciprocations per minute. It is currently set to 60. Touch the number for speed. Let's choose 30 reciprocations per minute. Tap 3 and 0 and enter. Press the home button to go back home. To run a test, press the start-stop button. You are given a confirmation button to actually start. Tap the green Start button. Now the machine is running. The count is updating. The machine will stop when it reaches the target number, but I will stop it by pressing the Start-Stop button. The machine stops. There are some additional controls on the touch panel with the DMLHP and DMLHPR motor drive units. Please refer to the Yuasa CS setup video. Now I will attach the FT jig to the motor drive unit. Let me point out first that the FT has a maximum allowable reciprocation rate and angle. I recommend that you have the motor drive unit set within those limits before you attach the jig. The maximum speed of the FT depends on which motor drive unit you are using. The TCDM111LH and the DMLHB with the FT jig can operate from 10 to 90 reciprocations per minute. The DMLHP and DMLHPR with the FT jig can operate from 5 to 90 reciprocations per minute. The maximum reciprocating angle is plus and minus 90 degrees on all the motor drive units with the FT jig. Our current settings of plus and minus 90 degrees reciprocation and 30 reciprocations per minute are within those limits. The first step in attaching the FT jig to the motor drive unit is to attach the connecting base to the bottom of the motor drive unit. Remove the 2 screws from the bottom of the motor unit. Use the screws to attach the connecting base to the motor drive unit. Make sure you have the screws tight. Now I will attach the rotary output flange to the rotary output shaft. It requires a 2.5 mm hex wrench. Note that, as I said earlier, the rotary output flange may already be mounted on the rotary output shaft. For example, when FT machines are shipped from the factory, the output shaft flange is already installed. Now we can attach the FT jig to the motor drive unit. But first, guide the controlling string through the jig, through the rollers, under the 2 pulleys, over the next pulley, and through the adjusting hole. Next, connect the jig to the connecting base. Remove the 2 screws from the connecting base. Put them through the holes on the jig. Lift the jig over the connecting base. Start the screws and tighten them. The next step is to install the swing plate. Insert the locking latch to hold the motor at the 0 angle position. I have already removed the port cover and lined up the locating holes. Note the idler and the adjustment scale on the swing plate and the idler adjustment on top of the swing plate and the 4 mounting holes. Use 4 screws to attach the swing plate to the flange. The screws are a little tricky to install. Move the swing plate to a horizontal position and tighten the 4 screws. Place the controlling string loop over the idler on the swing plate. Next, we can attach the sample clamps. I already have 3 in place. Each clamp is held with 2 bolts. The bolts have a hex head on one end and a hex socket on the other end. Insert the bolts from the bottom by hand. Tighten the bolts using the hex wrench from above. Because you are adjusting the bolts from their bottoms, you must turn counterclockwise to tighten them and clockwise to loosen them. Now the installation is complete and we can test a sample. The FT jig is one of Yuasa's tension-free products. No tension is applied to the sample while it is being twisted. When you twist a planar object that is held rigidly at both ends, there will be tension on the sample because the corners on the sides will be pulled farther apart as the twisting angle increases. The controlling string is attached to the idler on the swing plate at one end and to the following clamps at the other end. As the swing plate rotates, the controlling string will pull on the following clamps to keep the side clamps the same distance apart. My sample is a screenshot of my own smartphone magnified 2 times to make a larger sample, and then printed on paper. It is 130 millimeters wide and 230 millimeters long. For my first test, I will twist the sample between -45 degrees and +45 degrees. The maximum twist from flat is 45 degrees. We need to set the reciprocation angle for +45 degrees to -45 degrees. We set the reciprocation angle to be the total angular movement. The total angular movement is 90 degrees, so we set the reciprocation distance to be 10 on the reciprocation scale. I have already done that. Next, we will calculate the setting for the controlling string. We will use this calculator. As you can see from the equations, it is complicated enough that a calculator is desirable. My sample is 230 millimeters long and 130 millimeters wide, and the maximum twist angle is 45 degrees. The calculator gives us the value of 17.24 for the idler position. If you do not already have this calculator, ask your Yuasa contact for a download link. Now we will adjust the idler position to 17.24. The idler is on the swing plate and it adjusts from the top, but first loosen the idler locking nut. Set the position to slightly more than 17 on the scale. You can see that I am moving the idler up. Tighten the nut on the idler to lock it in place. Next, adjust the clamps for the sample width. Adjust the clamps on the swing plate to be spaced apart exactly the width of the sample, 130 millimeters, at the centers of the clamping pads. Now adjust the clamps on the base plate to be 130 millimeters apart at the centers of the clamping pads. Next, adjust the clamps for the sample length. There are two steps. The first step is to set the position of the base plate. The second step is to set the length of the controlling string. In the first step, we set the clamp spacing to be 15 millimeters farther apart than the length of the sample. My sample is 230 millimeters long, so the base plate is adjusted to make the centers of the clamping pads 245 millimeters apart at the centers of the clamping pads. Tighten the base plate at that position. For the second step, push the clamps 15 millimeters away from their end point, where they are being held by the spring. The centers of the clamping pads should be 230 millimeters apart. Tighten the controlling string clamp. The clamping pads should be exactly 130 millimeters apart on the width and exactly 230 millimeters apart on the length. Finally, we can mount the sample using the clamps. The four corners of the sample should be at the centers of the holding pads on the clamps. Now we can run the first test. Put the safety cover in place. Reset the count. I am setting the target to 20. I am setting the speed to 90. Press the Home button, then the Start/Stop button, now the Confirm Start button. The test is running with the sample getting twisted 20 times between -45 degrees and +45 degrees at a speed of 90 times per minute. And my first test is complete. For the second test, we will twist the same sample in one direction only between 0 degrees and plus 90 degrees. Because the total angular movement has remained at 90 degrees, I do not need to adjust the cam follower, but I do have to adjust the position of the swing plate. I have removed the safety cover. I have removed the sample. Use the Jog button to move the swing plate to the full counterclockwise position. I need to adjust the idler to get it out of the way of the bottom screw. Loosen the idler lock nut. Move it down using the idler adjustment. Loosen the 4 screws holding the swing plate to the output shaft flange. With the 4 screws loose, rotate the swing plate to be horizontal. Tighten 1 screw holding the swing plate to the output shaft flange. Use the Jog button to operate the swing plate throughout the new range to make sure it is from 0 degrees to plus 90 degrees. Now tighten all the screws on the swing plate. Returning to the calculator, we will use the same 230 millimeters length and 130 millimeters width, but the maximum twist angle will be 90 degrees. The calculator gives us the value of 21.92 for the idler position. Now we will adjust the idler position to 21.92. Following this adjustment, we would set the clamps for the sample width and the following slider for the sample length, but we don't need to because we are using the same sample. But we do need to adjust the controlling string. You adjust it like before so that the clamps are held 15 millimeters away from the end of the base by the controlling string. And now we need to tighten the idler lock nut. I already readjusted the controlling string, and I already mounted the sample. Now we can run the second test. Put the safety cover in place. Reset the count. I am leaving the target at 20. I am leaving the speed at 90. Press the home button, then the start-stop button, now the confirm start button. The test is running with the sample getting twisted 20 times between 0 degrees and plus 90 degrees at a speed of 90 times per minute. And my second test is complete. This concludes the Yuasa FT setup video.